Hello, ladies and gentlemen. Today we are still in Unit 6, Systems. And your target today, which is actually going to last you for a couple of days, is I can solve a system of linear equations and explain why a system may have no solution, one solution, or infinitely many solutions. Today we're going to focus on the solving part by using substitution. And then tomorrow or the next day, we will focus on how do you know if it's no solution, one solution, or infinitely many solutions. When this video ends, send a picture of your notes if you are learning from home today. Students who are in the room, you will simply show your notes to your teacher. Please send the picture via reminder email, not as an attachment in Google Classroom. So pause this video, get your target down, and also make sure your notes are neat and organized so that you can look back at them and use them to help with assignments. I'm going to start off by reminding you of how you graph, how you solve a system by graphing, because we just spent the last week doing that. To solve by graphing, you need to remember that an equation in the form y equals mx plus b gives you everything you need to graph. You will begin with b, so on the top equation, I would begin with 2, and then you move with the slope or the rate of change, and my rate of change is negative 3 over 1. So I'm going to go down 3 over 1, and it's a good practice to fit as many down 3 over 1s as you can on the graph. And once those all fit, then you go up 3 and fit as many as you can. So I was able to fit 4 points. What that does is it makes it a little bit easier for me to make a straight line. And you guys can see I'm still struggling with that. The second equation, y equals 2x minus 3, also gives me everything I need. So I'm going to start on negative 3. And my slope is positive 2 over 1, so I'm going to go up 2 over 1. I can already see where those two lines are going to cross, up 2 over 1, as many times as I can fit it on this little graph that I have here, and the reverse on the other side of the y-axis. And here's my sort of straight, nope. However, I can still tell that they were supposed to cross at 1, negative 1. So my answer is xy 1, negative 1. This means I can plug in 1 for x in either one of these equations, and my answer for y will be negative 1. Now, what we're going to be learning this week is called substitution. And so today we're going to start with the equal values method. Equal values means I have two things that it says y equals. Y equals negative 3x plus 2. Y equals 2x minus 3. Since they are both equal to y, I can take the two parts and set them equal to each other. So I'm going to take the first one, negative 3x plus 2, and I'm going to say that that equals the second one, 2x minus 3. Now, what you should notice after I've done that first step, y is gone. Now I have an equation with one unknown. And this is like what we did at the beginning of the year when you had a variable on both sides of the equal sign. Once I realize that I have an equation that can be solved, I'm going to separate the equal sign, two sides, went all the way down. Maybe I need to go that far, maybe not, but I've prepared myself to have room to do multiple steps. It doesn't really matter if you leave x on this side or if you leave x on this side, but most people prefer to get the variables on the left. So I'm going to say get variables or get x to the left. So to get x to the left, that means I don't want it on the right. So this 2x, which is on the right side of the equal sign, I'm going to cancel it out by subtracting. 2x minus 2x is 0. That means I also have to do a minus 2x on the other side of the equal sign. Negative 3x minus 2x. If you are not sure whether that's a 1 or a 5, I highly encourage you to use your Desmos calculator and type in -3 minus 2 in a situation like this. It is -5. Bring down the +2 that I didn't work on. Bring down the -3 that I didn't work on. Now I want to get my constants to the right, which means I don't want them on the left. So 2 is a constant. I want it moved to the right side. So I'm going to move it to the right side by subtracting 2. This cancels. And I have -5x that I'm going to bring down. And -3 minus 2 is -5. And then I'm going to use the inverse operation of dividing by -5. -5 divided by -5 is 1. Right here is a big 1. 1 times x is x. And still, -5 divided by -5 is still 1. So I have the answer x equals 1. Unfortunately, I am not done. In order to be done, I have to go back up here and I have to know what x and y are. Since I started with 2 unknowns, I started with I don't know what x equals, and I don't know what y equals. So when I finish, I need to know what x and y equal. So with that work, and guys, I know it took a few minutes for me to do it. That's because I explained every single step. With that work, I only have x, so I still need to get y. This is called the substitution method because once you have x or y, you can substitute it into one of your original problems. So in this case, I'm just going to use this top original problem right here, and I'm going to substitute x equals 1 inside it. So y equals -3x plus 2, y equals -3x plus 2. That's not a 2. There's my 2. In the place of this x, I'm going to put this 1 in that I just got from solving that equation. And then I'm going to work this out. -3 times 1 is -3. And then -3 plus 2 is -1. So I have x equals 1 and y equals -1. I can take that and write it in an ordered pair. And it is the same ordered pair as over here where the lines crossed. Crossing the lines, if you have them written both as y equals and y equals, absolutely it makes sense to do what we did last week, to go to your Desmos calculator and type them in and just see where they cross. But you're going to find out in the next couple of days, they're not always written as y equals and y equals. So today we're going to show you how to do it with y equals problems, the substitution method, so that when it gets harder, you'll still understand that it really does get the right answer. This got -1 for y and x +1, this ordered pair, got the same ordered pair by doing it by substitution. Y was -1 and x was +1. Ordered pair x, y, 1, -1. Okay, I'm going to do that again 2 more times. Make sure you are taking excellent notes so that you can look back and see what's going on. So the first thing I'm going to do is I'm going to take y equals 3x plus 5 and y equals 4x plus 8. And I am going to set those two things, since they both say y equals. Yes, I could put it in Desmos and I could see where they cross, but I'm going to do that with pencil and paper. So the first thing I'm going to do is I'm going to take this 3x plus 5, since it equals y, and I'm going to replace that y. So that would be 3x plus 5 equals 4x plus 8. So you guys can see my graphics pen went a little haywire there. 3x plus 5 equals 4x plus 8. Okay, 3x plus 5, 3x plus 5, 4x plus 8, 4x plus 8. I have a variable on both sides. So I'm going to move x first to the left-hand side. So it's going to cross the equal sign. When it crosses, it was positive. When it crosses over here, it's going to be negative 4x. I do like to write it on both sides and just cancel it out. 3x minus 4x is negative 1x. I still have plus 5 that I didn't work with, and I still have an 8 on this side that I haven't done anything to. Now I'm going to get the plain numbers, otherwise known as the constants, 5 and 8, over to the right-hand side. 8 is already over here. I'm going to cancel 5 off of the left of the equal sign and move it to the right of the equal sign with the inverse operation of subtraction. So 8 minus 5 is 3, and I have negative 1x. To get x completely by itself to be a positive 1x, I'm going to divide by negative 1, and I have x equals negative 3. Okay, as a reminder on these problems, when you start, you don't know what x equals, and you don't know what y equals. And since both of them are in the original problems, both x and y are in these original problems up here, you have to have an answer for x and y when you get done. So right now, all I have an answer for is x. Now I know that it's negative 3, but I still have to get y. And that's where the name of the game comes in, substitution. I'm going to just take my top problem, y equals 3x plus 5. But now that I have a number for x, I'm going to put the negative 3 in for x and work this out. Y equals negative 9. 3 times negative 3 is negative 9 plus 5. Negative 9 plus 5 is negative 4. So now I have an answer for y, and that answer is the ordered pair negative 3, negative 4 altogether. Altogether, the ordered pair is negative 3, negative 4. I am going to show you that this is true. So in math, you could always check your work. So I am about to check my work. I'm going to put negative 3 back in this other problem now for x. So y equals 4 times negative 3 plus 8. Y equals 4 times negative 3 is negative 12 plus 8. And guess what negative 12 plus 8 is? It's negative 4. So it did work out. You can check your work. Your answer should work back in both original equations. Okay, last time. We are given again 2 problems that both say y equals. So I have y equals 11 minus 2x and y equals x plus 2. Since they both say y equals, I'm going to take this 11 minus 2x and I'm just going to put it right here in the place of this y, right here. So now it's going to be 11 minus 2x instead of y equals x plus 2. Separate my problem into a left and right side of the equal sign and get the variable to go to the left. So I've got an x right here. It's positive x. When I move it to the left with the other x, it's going to be a minus x. I do like to show that I did it on this side to cancel. Be very careful. This is a negative 2. This is a negative 1x right here. Negative 1x. So whenever I put those two together, I actually have a negative 3x. Still going to bring this 11 down. And I'm still going to bring this 2 down on the other side. Don't forget to bring down the pieces that you haven't used. Now that I have the variables on the left, I'm going to get the constants, 11 and 2, to the right-hand side. 2 is already on the right. I'm going to move 11 over here. It's a positive 11 on the left side. As soon as it crosses the equal sign, it's a negative 11. So if I subtract it off this side, it's gone. I still have the negative 3x. And I do 2 minus 11, which gives me negative 9. Again, guys, I do math all the time. I can do 2 minus 11 in my head. Lots of you guys can do 2 minus 11 in your head, but I have no problem with you plugging that in the calculator just to make sure. My last step is to get x all by itself to be a positive 1x. To do that, I'm going to divide by this -3, and I get x equals 3. Seems like I've done a lot of work. Am I done? No, I'm not done. When I started this problem, I had 2 equations and there were 2 letters in it, 2 variables, 2 things I didn't know. I do not know what x equals when I start this problem. I do not know what y equals. So when I'm done, I need to know both of them. Right now, I only have x. So we go back to the name of the game, which is substitution. And for substitution, that means I'm going to substitute 3 in the place of x. Now, guys, I can do it in either one of these problems, but honestly, I like stuff to be as easy as possible. So I'm going to put it in this one this time. And I'm going to say y equals x plus 2. And I'm going to put 3 in there. What's 3 plus 2? 5. That was super easy for that one. So my final answer is the ordered pair x, y, 3, 5. Don't forget, you can still check your work with the other one that you did not use. So I didn't use the top one for substitution. So I'm going to check and see if 3, 5 works for that. So checking my work. Y is supposed to be 5, so that's y. Y equals 11 minus 2x. 11 minus 2 times x, which is 3. So let's check that out. 11 minus 6, yes, 11 minus 6 is 5. It checks out. So my answer is x equals 3 and y equals 5, or you can also write it as an ordered pair, 3, 5. Make sure you have neat notes, organized notes. If you're learning at home, you are sending a picture of your work through Remind or through email. In class students, you will simply share your notes with your teachers as we walk around the room. Next, you have some questions on delta, so use your notes to help you out.